There we go, live.
Yeah, live. Yes. Hi, guys. Bonjour. I will speak French, so John, you will be able to translate in English, right? Live.
Yes, I will.
I will. Bonsoir.
Good day.
Good day. Non, c'est bonsoir, so it's good night. So, bonsoir. Merci de participer à ce meeting-là. Ce soir, c'est notre premier meeting qu'on fait sur YouTube, sur StreamYard. Fait qu'on peut avoir des petits hiccups, mais ça devrait aller. Donc, on va essayer d'en faire d'autres d'ici la fin de la saison qui devrait être au mois de juin. So, I will translate in English. So, good evening. It's going to be it's the first meeting we're doing on StreamYard tonight, and broadcast will be on YouTube at the same time. So this is one thing. We might have some hiccups, but we'll try to improve. The other thing is we try to do one or two other meetings before the end of our season, which is of June, which is in June or July. So now let's talk with Mr. John Miner. Miner, do I have the right pronunciation, John?
You got the perfect.
Perfect. All right. So
but
John,
Christian, maybe before we should give the participants the email address if they have comments or issues they can email us. Okay.
Sure. Yeah. It's we have a new email address. Thank you. And Michelle. Yeah, this is Michelle. You all know Michelle?
Yes. So it's MTL, like Montreal, MTL data platform @outlook.com.
Yeah, I'm sharing that. Yeah.
MTL data platform @outlook.com, and Christian, you're going to share it on the meetup.
Yeah.
Okay, good.
Yeah, it's done.
Excellent.
All right. So, John, you're on.
Awesome. I'll take it over. Thank you, Michelle and Christian, fellow MVPs, to invite me to graciously speak tonight. I'm going to do a little intros, and then I'll hide myself, and we'll do the presentation as well as a bunch of demos, okay? Let me show you what I have on the tabs up top. So on the tab up top, I have a GitHub repo that has all the community presentations, and I have the actual presentation here. So if you get lost, you want to see it again, it's there. And I have the code samples. So they're also in Python or IPython, which is Jupyter Notebooks, or a dump in for Databricks, okay? Let's close that one. I've actually done this before. This is like the 4th or 5th time. So I did this already. So if you're curious and you want to compare channels, I did this about a month ago, and you can check out this YouTube URL and you can check about it. I always try to do it a little different. So tonight, maybe I'll mix it up a little. If you're curious, this is about me. I actually present on MS SQL tips. I write about 75 articles. One of the things I want you to pay attention to is this one, Azure Databricks Local File Management System article. Some of the components I'm going to talk about that today are in this actual article, and it's a nice companion piece. What else we got? Yes, I've been an MVP. This will probably be my 6th year, and it's really fun meeting people. I think, I really got most of my skills from PASS. PASS is no longer around, but Data Platform still survives. Is Data Saturdays, and I'm looking forward, hopefully, Montreal and or Rhode Island. I run the Rhode Island user group. We'll have SQL Saturdays in the near future, okay? So with that said, I'm going to be talking about Azure. So if you haven't done anything with Azure yet, then you probably want to get a subscription. And one of the things I'm going to talk about is I got a bunch of components that I pasted up here, okay? And these components are part of what Microsoft calls the modern data platform, okay? And so we're going to get into that. And also, this is Databricks, and I'm going to give you a quick peek. I'm just going to make sure my cluster is running. But Databricks is built upon a distributed processing system, okay? I like to think of it as divide and conquer, right? So you have one node, which is the driver, say the master, and you got a bunch of slaves, other workers, right? And basically you're going to divide up the work and give it to the workers to actually do, okay? So with that said, let's go back to Steam. And again, if I'm doing a little clicks, stop mic. Does it stop the mic too?
No,
so
John,
I guess
I simply removed you from the screen, so you're okay now.
Okay,
Just
excellent.
present. Yeah.
Okay, so I'm presenting and you see me? Awesome. So,
You cannot see you. Now you see your full screen. Yeah.
okay, so you see this? This is
Can
perfect.
you,
That's
yeah,
what I was
can you
looking
click
for.
on stop sharing on your screen?
Yep.
Yeah. No, just hide it.
Yep, hang on.
Yeah.
Oops.
Sorry.
Give me
Yeah.
a second.
Yep.
Windows is not talking to me and hide. Okay.
Okay. Okay, we get
And
thanks.
then sometimes Windows doesn't want to talk. It's like, hey, okay. So hopefully you see this and hopefully you don't see the side. Do you see the
Yes,
presentation view or you see the full view?
the full view.
Awesome. Then I'll continue from here. So we're going to go through a bunch of slides, and this is kind of the background of what Azure Data Lake is and what I've been taught. Okay, and hopefully I'm teaching you the correct terminology. And we'll go over the components that are going to be part of the solution, and then we're going to talk about basically Databricks and how to transition what you've probably known like me. I've been doing T-SQL since 1996 was the first time that I actually used SQL Server. It was 6.5, okay? And I've been using it, oh, wow. So 4, that's 20, right? So 25 years already. So the purpose, many companies are moving their workloads from on-premise operational data stores to in-cloud data lakes, right? So the Spark processing data platform is a key player in this transition, okay? So as a developer, you want to kind of re-leverage the skills like I have and you have over the decades, right? And try to take advantage of this growing segment. So how can you do that? How can you learn how to be proficient in this big data technology? So today we're going to talk about the concepts and I'm going to show you some code and how to get you just started, okay? So topics, what's Spark, right? I didn't really hear about Spark until about 3 or 4 years ago. When I was working at Microsoft, they said something about Databricks. And I looked at it initially, I was like, oh, okay, that's great. And back then, Microsoft was pushing USQL. And, I did a lot of work with USQL. But, ever since I started using Spark, I like it a lot. And there's a lot of products out there that are using Spark. For instance, Synapse, Azure Synapse is a new product out there. And it's trying to compete in this space, okay? So there's going to be a bunch of things you need to worry about when you actually work with big data. And basically, most people are transitioning from these data stores to a data lake. And what is a data lake? We're going to talk about that. We're also going to talk about how do you work with the files, because that's what the data is, right? Yeah, it's a CSV file, it's a JSON file. Maybe it's an image if you do an image processing. We're not going to talk about that tonight, but it could be an image, right? It could be streaming data from Event Hub. So there's many different ways data can come in, but eventually they get stored as a file. And we're also going to talk about folders, okay? The most important thing is before we can do any SQL, we have to read or write the data, right? So we have to know that. And then once we read and write the data, we can actually take that and post it to a Hive catalog. Once that file is posted as a Hive catalog, you can use a lot of the SQL constructs, ANSI SQL, that there is some differences. I'll point at least one of them out tonight. There's not enough time to go through all the actual Spark SQL commands out there. There's a couple hundred, and I could spend a whole hour talking about it, okay? Last but not least, we'll talk about some functions and some known differences, like I said. So what is Spark? Spark is a unified processing engine that can analyze big data, okay? And it's right in the middle here. So I'm going to bring my cursor over if I can find it, and it's Apache Spark. Okay, underneath the hood, Apache Spark is basically written in Scala, and Scala is object-oriented Java. So it's just a bunch of Java running on basically a bunch of servers, right? Or, virtual machines. And so you can do many things with it. They've been bolting on things for last half decade. So first thing is you can read it in a data frame. So it's just like pandas. You can read the data up into a data frame. What is a data frame? It's kind of like a table, right? It's a single table. You can join data frames. Not that easy to do. You can do a lot of functions on data frames, but you have to really know what the syntax is. I like SQL. So once you post that file to the catalog, you can do SQL. But there's also things you can do like graphs. Say if you have the traveling salesperson problem in which you want to go from Montreal, where my friend, Christian is, and he wants to go talk at SQL Saturday in Province. How do you get there? Maybe he wants to go through Quebec and say hi to Michelle. Or maybe he wants to go through Albany and stop and talk to Ed, right? And then come to John's house, right? So that would be a graph problem. And maybe he'd want to know what's the shortest distance versus the shortest cost, right? So there's a couple problems you could solve with this technology. Streaming. Well, everything we consider is in these data frames is usually batch processing. And even with streaming, it goes into a data frame. But I consider this mostly batch. Streaming is when you're getting stuff in real time and you're actually writing it to a file. We're not going to talk about about that tonight. Last but not least, Spark has its own ML libraries, okay? What's different about them versus regular ML libraries is that it's distributed, so it does that divide and conquer, okay? We're not going to talk about that tonight too. Maybe in the future, I'll do a presentation on graph streaming and machine learning. So let's talk about the Databricks cluster. Well, like I said, the Databricks cluster has one driver, okay, and a bunch of executors, or I call them workers, okay? And so there's a couple things you really need to know about the cluster, okay? First thing is that when you start a job, it starts on the driver, okay? And a lot of times when you go ahead and use OS commands, they're only on the driver, okay? So if you try to, say, copy a file using the OS command CP from a magic command %fs, ls, or something like that, right? And you do CP of the file from one directory to another, it does a file copy, just like you're in Unix, right? The problem is it only runs at the driver. Anytime you do spark.read, spark.write, guess what? That stuff runs across the distributed node, okay? And it's interesting because it's the actual way it divides it up, it depends upon partitioning. So it's very interesting that the bigger the data is, the more you have to worry about partitioning. So in the next example, maybe there's a couple of jobs running, but say if I had a file and I partitioned it by 4, and I had this example up here with 8 slots, then more than likely, maybe it would say, hey, run one task on each slot, and it depends on the executor code how to do that. Or maybe it would say run it on 2 of them. Again, those are the slots, and that's how parallelism works. So let's talk about the optimizer. This is just like SQL Server, but just a little different, right? So the optimizer, okay, is one in which you basically, regardless if you're using a data frame or SQL, and I haven't talked about data sets. So what's different about data sets versus a data frame? They're pretty much the same, but there's a couple languages that are tightly bound, like Java and Scala. So not only is a data set like a table, like a data frame, but also it's strongly typed, okay? And that's the only difference, okay? But regardless of whatever technology, you can see there's 3 different interfaces to read data. You still have to come up with a way to retrieve the data from actually the storage, okay? And so that means we have to come up with a logical plan first of how we're going to execute it. Then we're going to have to optimize it. So we're going to say, hey, you know, maybe we're going to hash some data over. Maybe we're going to do shuffles, and shuffles are bad things, as you know, in distributed processing, because I need to move data from one place to another. It's not a good thing, right? And then we're eventually going to come up with a physical plan. And once you get that physical plan, what you're going to do is you're going to apply a cost model to it. And the cost model is basically going to say, hey, you know, how expensive is plan A to plan B? And it's going to select the plan, okay? Now, if you don't remember anything else tonight, I'm going to tell you one thing, RDD, okay? And that's where all the magic happens. Resilient distributed data sets are in-memory, immutable object, okay? And what does immutable mean? When I read, say, sales from a parquet file, it creates an RDD underneath the data frame. Then if I take that data frame, say I add another field, say I had quantity in cost and I want to know unit cost per that line item, say in sales. I could take those 2 columns, multiply it, and create a new column. But in reality, maybe we set it back in the code to another data set. But in reality, you know what it is? It's actually creating another object in memory. And it actually takes the old stuff and then puts that new column in, okay? So that's why it's immutable. And when you write it back, guess what? Then the RDDs get released. And again, this is not a course about low-level RDDs and how to do it. No one does that nowadays. Back, say, 8 years ago, you had to worry about Scala and, you know, understand the 600,000 lines of Spark. We're doing it all high level nowadays, so it's data frames and SQL. But it's good to know the difference, okay? And one key difference between open source Spark and Databricks and or Azure Synapse is the optimizer, okay? So these companies are trying to make the process of executing your code better, okay? How can it run faster? How can it be optimized? And that's where the key difference is. So let's review Databricks service. I'm going to talk about workspaces, clusters, importing files, Hive database, notebooks, and jobs, okay? And so this is demo 1, read and write files. Okay. So this is read and write files. And so this, okay, is basically called the notebook, okay? And so what I'm going to do is I'm going to close out of here, I know that my cluster is running, and I wanted to make sure it was running because that's one of the things that's the most expensive thing about Databricks is in time. It takes some time to spin up a cluster. Now, what is a cluster? Well, we can see there's one virtual object here, right? And it says an Azure Databricks service. But in reality, when we spin up a cluster and what it's doing, it's actually spinning up virtual machines. So we can see if we clicked on this and hit see more, okay, we're going to see that there's 3 different virtual machines. And the reason why is that there's that one executor node, okay? And then there is, where's the network interface? Maybe there's more on this one for some reason. Maybe I spun up more, but there is only 3. So right here we can see there's 1, and it's some type of GUID, another GUID, another GUID. I don't know which one's which, but one of these is the actual executor node, and the other 2 are the worker nodes, okay, the slots, okay? So if we go back to the dashboard, okay, a little about this, there's also storage count. Now, I want to talk about local versus remote storage. We're not going to get into remote storage, but you can attach, okay, to the data lake, and that's where all the magic happens. When you attach to ADLS and or S3, you can manipulate the files, read a file in, transform it, and then write it back out. We're not going to do that today, but there is a local account which we can copy files to, okay? And it's this storage count right here. If I click on it, what we're going to find out is that I don't have access to it. And that's because it's a private storage account. So if I click container, and you can see this is my jobs, this is my metadata, is a root, the root file system. But when I actually go into it, it's going to give me a request failed, okay? So I've given you a little idea of what the service is. It's a bunch of VMs, and what's the local storage, which is a managed storage that you really don't have any access to. But there are ways to copy data in. We'll talk about that. So we're going to launch the system now. And every time you do it, you have a workspace. And this has, at the top level, you have RBAC, right? And RBAC is you can either be an owner of the service, or you can be a contributor or a reader, okay? And if you're interested, we can go into the portal. Whoops, wrong one, sorry. I think it's this one, I always forget. Question mark, nope. This one right here. So we can go into the admin console, and what we can do is we can add users, right? So in the users, we have Dilbert. He's an admin, okay, and his Crafty DBA. So I'm logged in as Crafty DBA. So if I did not want to have Dilbert, in here, I could say, hey, let's not make him an admin, right? And then we go back, and that's it. So he's no longer an admin. We can also say, hey, can he create a cluster or not? So a cluster, let's talk about them. This one's running, and it has 3 nodes, but there's 3 types of clusters. So if we hit create cluster, okay, the most simplest one is a single node cluster. I suggest you don't do it because it's just academic, okay, in nature. You're running both the worker thread as well as the executor thread, okay, on the same node, okay? So you have the driver and the executor, which is the, master versus slave, whatever terminology you want to use for distributed processing. And you can pick a runtime version. Runtime tells you what version of Spark. So for instance, if I wanted to have Spark, not Spark 3, which came out, but if I wanted to run a version earlier than Spark 3, maybe 2.45, I could go back to 6.4. It also tells me the version of Scala, and there's also a bunch of other settings. There's advanced options in which you can add stuff to the cluster. Like right now, this is saying single node, so that's what it does. There's environment variables you can add. So there's a lot of things that you can tweak here. What's the interesting thing, though, is you can also do credential pass-through. Okay, we're not going to talk about that. But a single node, again, is academic. Most people will use an interactive standard node, okay, and hit confirm. And a standard node, usually you can give the minimum number of workers. So I'm always going to start off, and because I have 3, because I have 1 driver node and 2 worker nodes. But if I want always 8, I could hit this and make it 8. And if I took that and changed the cluster I have spinning, stop it and restart it, it'll suddenly come up with 8 VMs. It'll just take longer to stop. A key point here, though, is to make sure that you click this button right here. Make sure it's terminate after, and put a number in that's reasonable for your business case. So for instance, if we look at the ABD, so Azure Databricks training, we can see it's at 120 minutes. If I want to save money, I could say, hey, terminate at 30 minutes. If no one's using the cluster after 30 minutes, it just turns it down, okay? The last cluster is something called high performance, and that is basically restricted only to the Python language. And again, I talked about languages, right? So Scala is one of the languages that's supported. Python is supported. You can do R and so on. Let's talk about a workspace. And we're going to get back to those languages, okay? So there's two types of workspaces. There's a shared workspace and a user workspace. So if I went to Crafty DBA and I went to my first program, right, I can create a program called Hello World. Now, if I run all and click run, it's going to say I can't run because I don't have any cluster to run it. So I'm going to tell it to attach. And if I run, guess what? I get, it's interactive, right? It's print hello world. And say if I wanted to create another one, and I say print, right? And then hi Christian, you can spell, right? And I shift and enter makes it run. We have hi Christian. So we got two of them. So not only is it interactive, but it's also whatever you do here stays in the cluster memory, right? So if we went ahead and we did x is equal to Christian, right? And then we print x, right? We're going to see that that remembered what Christian was. But then if I went ahead and it's just like basics, it's interactive, it's interpreted, it's putting stuff into the memory for this connection. And now guess what? Changes to John. So I just showed you how to do that. I also showed you that this is a Python program, right? If we wanted to go ahead and start mixing languages, we can do that. So I can use something called a magic command and do Scala. So if I want to do Scala, I could say x var y is equal to Christian, okay? And then if I print y, and now guess what? This is going to run, but it's going to run as a Scala program, okay? And hopefully I didn't do, oops. So guess what? John's language ability is not too good. It's probably double quotes, and if not, I'm going to skip it all together because I'm not a Scala expert. But there you go. So you can see it's strongly typed because it's object-oriented. So it's Christian. It's a variable string, and that's the value, okay? So we showed the first program, okay? We talked about, haven't got there, and I'm going to quickly go over it, data. So data allows you to actually take that file that's stored on storage and actually abstract it, okay, so that it looks like a table. So we can, I have here the New York City one that we're going to do tonight. I also have dimensions for VentureWorks. So let's see if this is connected. So if we go to count and we click into it, and what you have to have is first you have to have a cluster for this to work. But it's going to say, hey, this is the structure, okay, because it's probably strongly typed. And then it's going to try to grab some sample data. Now the question is, if it's remote and I didn't run a procedure to connect to remote storage, it may fail. But in this case, it doesn't fail because I see 20 rows, okay? So let's go. So we did workspace, recents, whatever I recently looked up. It just shows up here. So I had first program, I could do this one. Clusters we talked about. Jobs. Jobs is how you actually schedule something. So say if I wanted to schedule my first program, right? It's kind of stupid, but we could, right? It's not a big program. It just says, hey, print hello world. But I could just do job first program. And then what I can do is I can select the schedule, right? And so scheduled, and I could say run it, say at the top of the hour. So we can go down to 19 and change this to 00. I can do it maybe. There we go. And then I can say, okay, I want to run this notebook. So I'm going to users, right? And I'm going to go crafty DBA, and I'm going to do my first program. Oops. Confirm. Okay, so it picked my first program. It's trying to give me a big cluster. Look at this. It's a new job cluster, 36 cores. That's huge. So I'm going to edit it. And I could say, you know what? I really don't need something like this. I could just do like maybe 4 cores, 1 worker, because I'm just saying hello world, right? And hit confirm, right? And notifications, I could say start, success, and failure. And so I put failure here, and we could also say success. Okay. And now we can hit create. And now it created a job. And so if we go to jobs, we're going to see it's our job, right? One worker and 8.1, and it's scheduled to run at 7 p.m. And so let's run that. We can also force it to run by hitting run, and successfully started the job. Okay. And so if we click at it, it's going to say run. And this is the Spark UI. So the Spark UI is how it's going to execute it. So we can go to logs, and we can say it's going to have to spin up that one machine. So if we go back here and multitask, okay, and go to the dashboard, the job cluster is totally different than an interactive cluster. So it's not going to reuse it, right? So it has to spin up another cluster. In this case, the cluster is one of them. And if we see, we're eventually, I think, probably going to spin one up. Okay. So it's still thinking, and see it says pending. So I'm going to let that run. We're going to come back to it and see if it finishes. Models, we're not going to talk about that, but that's where you would be doing your ML. I want to go to home and talk about some things you can do in home, which is really cool, right? So one of the things in home is you can actually import and export data. And so say if I wanted to go ahead and bring a file up, I don't know. Let's see if I can find, I usually have some stock data, old stock data hanging on my system. So let's see if I have some inbound data. That's my HTML. How about my outbound data? Okay, here's one. So I have, someone was talking about Apple, right? So APPL. Let's see if I can find it. Amazon, let's do Amazon because we're talking about Amazon too. So I got an Amazon file here in my outbound directory. I just want to analyze it. How can I analyze it, right? So what I can do is I can upload a file, right? And it says just browse to it, right? So I'm going to browse, right? And I'm going to go down to stocks. Okay, I'm going to outbound. I'm going to go to N because it was Amazon, right? Unless maybe now it's somewhere in between. AM. Here we go. Amazon. Hit open. Now it placed it automatically in a local file storage called File Store. Okay, tables Amazon.csv. Now I can say let's create a table with the UI, right? And so, or we can create a table in a notebook. So maybe we'll just create a table in a notebook. Okay. So now it's saying, here's the location of the table, the file type CSV. Do I want to infer the schema? It says false. I don't know why it's saying false because you're probably going to infer anyways, right? And then first row is a header, it says it isn't. Delimited a comma. And then we're going to do, this is one of the things you're going to have to learn tonight is there's a bunch of options for spark.read. So one thing is the format, and we can say spark.read.csv, or you can say .format equal to. Option is it a separator, header, and so on, and then load the location and then show it. So what we're going to do is for this to run, we're going to attach it to a cluster, and we're going to run it. And if we look at the Spark job and take a look at it, it does something called stages. So stage is how it actually pulls it in under the hood. And again, we don't have enough time to do it in detail, but basically going to scan text and it's going to create some code. That's what it does there. And if we look at the second one, and this is a diag, says scan CSV, and we can see what, if any, output there is. This said successful on this one. The other one, if it's something that's really complex, it might show us a couple, nodes that's running on, but this was very, very simple. And we can actually see that it came out, but guess what? It guessed wrong because the first row, we actually have a header. So it's easy enough to change, right? We go true, and then we run this again, and voila, and now we got our header here, okay? And so what we can do is we can create something called a temporary table off a view, okay? So now we can take that data frame and we can create or replace a temporary view called Amazon, and now we can query it using SQL, okay? And this is how a pattern that you can use over and over again. Now, the interesting thing is when we create this table, it's not actually doing anything. In fact, let's do this. Let's comment out this line, and I'm going to run this one. Oops, it didn't do anything. Okay, and I run this one. It still didn't do anything. So, Christian, you paying attention? What is this called in Spark?
What? Magic keyword.
Magic keyword is lazy evaluations, right?
Yep.
And so at this point, what we were doing is that when I ran this one, there was nothing going on because I didn't tell it to do an action. These are all lazy. This says, hey, this is what I want to do, but we didn't do an action called display as an action. And when we did this, there's no action. We're just creating it. But when we actually run the select statements in action, okay? So that's pretty much it. So I think I did a really good coverage of the Databricks service. Let's do some more terminology, and then I'll get into the final demos, and we'll go deep on some demos. And what time is it at 7:30, or can I go a little longer?
Longer.
Okay, excellent, excellent. So data lake zones and data quality, okay? So again, we talked about Lambda, and Lambda has usually two things. You can do streaming and you can do batch. We're talking about batch today, and there's something called near real time, right? Near real time means that I'm going to run it maybe every 5 minutes. It's going to be quick. I'm going to get these incremental files from my source and do it. Versus streaming would be, hey, I'm getting it because I'm getting a lot of IoT data, okay? Now, typically when you create a data lake, you create zones, okay? And some people call them bronze, silver, and gold. Some people call them, I like to call them raw, refined, and curated, okay? Raw is where you dump stuff that's raw. So for instance, at a current place I'm working for a hospital, I dump the tables from Clarity as raw, right? But because the big tables are huge, I can't copy them all the time over. So what I do is I seed them with a full load, and then daily I get incrementals, okay? So those incrementals will go into raw, but in Silver, I'll have something called a delta table. And in the delta table, I'll upsert into the delta table. And guess what? The delta table will be logically consistent with the on-premise SQL Server table. So that way, those combination of parquet files and the way delta works, it looks just like a SQL table, and it's smart enough to know that, hey, if I had to delete a record or insert a record or update a record, it gives me the right stuff. And last but not least, we usually consider gold, or the curated zone, is like where we take the data and refine it. So for instance, if we're ultimately creating a star schema that's going to be used by Power BI, because Power BI loves star schemas, right? Then that's where we'd do. If we were going ahead and maybe didn't clickstream data, and we're trying to do analysis of, how many pages does this person look at, we could do counts there and show it. And last but not least, we can do AI in it if we want to do machine learning, or we can do reporting, which is Power BI. So one of the things that I want you to pay attention to is some ideas coming up, because these are very important, right? If you don't know what's in your lake, you got a data swamp. A lot of people call them a data lake. I call them a data swamp when I see something that doesn't have a data dictionary, okay? And so one of the things I do when I do a metadata-driven approach is to keep track of the data dictionary or even a data catalog. Hey, what's the file? Doesn't have to have the metadata schema. You could still capture it if you want, but it has to have, the file, the type. Did I replace it? Did I insert it? And, so on. So for instance, if we copied over a new record or a file, right, incremental to the raw zone, it would be insert and it would be parquet, right? And then if we upserted into delta, it would be an upsert delta, right? Now, if we repeat this thing for a full file, right, full load, then we would always overwrite. So the first one would be insert parquet, and then it would be overwrite or replace delta, okay? Various file types. There's two types of files that you can store in the data lake. There's weak type files and strong type files, okay? So weak type files, okay, usually have problems with, they can be easily broken. So for instance, if I had a CSV file and someone came along and inserted another comma, then the file might break, right? Also, there might be loss of precision, right? For instance, if I went to JSON, right, I have to convert a floating point number now to a text representation, right? And it could actually lead to rounding errors, right? Strongly typed files are better quality, and they're easily used or consumed because you know what the column of the name is, you know what the data type is. It usually supports compression, okay? So one of the things that most people are using nowadays is the Apache file format for Parquet. Avro is a great file format if you want to read really quickly, but Parquet is a better one for storing long-term. Give you example. Today I was working with a file that we're downloading. It was 56 gig in the database, and guess what? When I compressed it and got it into a parquet table, it was around 5 gig. So you can get some really great compression, and you can save some space in your data lake. We already talked about load patterns, but let's review again. So a full load is great when the target size is small and you can replace it again. So for instance, I have the counties in Rhode Island, or the states in the United States, or the regions in Canada. Those are very small things, and you know what? Full load them. You overwrite the Delta file, you're done. Incremental is great, okay, for small to medium size, because we're starting with a full, and then every time we run daily, we're getting changes. For instance, maybe we're doing sales and we have a new client, so we have a customer file, and it might incrementally add to it. Large data sets need to be partitioned, okay? So not only do we worry about saving data into a Delta format, but any of these formats we talk about, even Parquet, they have the ability to be partitioned. So we want to pick a partitioning key that lends our data to retrieval. And if we're only working on data on a monthly basis, then maybe we partition by month, and that makes sense for your organization. So let's talk about Delta. Delta is really exciting. I remember being at Microsoft actually I was at Insight. It came out in 2019, I think, just beginning of 2019 or 18 into 19. But the interesting thing is it allows you to have ACID transaction, okay? In the past, when you worked with a Parquet, you would have to read it up. And if you want to add records, you would take that data frame after you read it up, and you would add the records, and you have to write it back out. Well, when you work with Delta, you can write SQL and say insert into this table, and suddenly it works. So you can do the data frame. But either way, the transactions are ACID, so either they commit or they roll back. There's schema enforcement, okay? There's something called time travel. So I can go and say, hey, what did the data file look yesterday? And what did the data file look 10 days ago, okay? This snapshot isolation, so people can read and write at the same time. It's open source, so even Microsoft's using it. One thing to caution you with, time travel is there's something called vacuum. Vacuum allows you to repartition and shrink things. When you do that, then the amount of time travel you have will get reduced. So some of those files will get thrown away. There's also a default number of days. I don't remember off the top of my head if it's 10 or 35, but you can look it up online. So let's talk about the Databricks file system. Out of the box, Azure File System has a local file system for remote storage and can be either mounted or attached at runtime, okay? And there are many ways to work with files. So you can use these magic commands. %s means file system, ls means list, /temp means the temp directory. Some of the file systems commands or magic commands ask you to add something called a hot spark to it. So it means dbfs:/. So for instance, if we do sh, which is a bash shell, /ls, see we're appending, okay, the root name to the file. Also, if we're using OS commands out of Python, os.listDirectory, you have to append it, okay? dbutils is written, which basically boils down to FS here, or vice versa, okay? And that already knows it's hot sparked mount point, and so at that point, we can just do /temp. We don't have to append it, okay? Just remember, a lot of these commands you're actually running at the driver node, not at the worker node. So if you're trying to, say, remove a lot of files or delete a lot, delete a lot of files and move them, you might run into it taking for a long time, and that's because it's single threaded. So wrong way. So we did Databricks. What else? Oh yes. So PySpark, read and write files. So PySpark is a Python API. I could be talking about Scala. I could be talking about R tonight. Why am I choosing Python? Okay. I choose Python because I'm a data scientist. I've learned R and forgot about it because I just didn't like it. Nice thing about Python is that not only can you use it for, Spark or ML, but you can use it to automate things, right? So there's plenty of things you can do with it. You can automate the boring stuff with it, okay? The main two things you need to worry about is Spark.read allows you to bring in a file as a data frame, and Spark.write allows you to take a file and write it out. Also remember, when you write a file out, it's not a single file, but it's partitioned into n files. So there's going to be multiple files there. So let's read and write files as our next example. Okay, so we're going to go back to being very structured now. The very first part is a little loosey-goosey. I go around, talk about it differently each time, but we're going to get into really something structured because I got 4 examples I want to go over. So read and write files. So again, you always have to have a cluster. This right here is called the Markdown. Markdown is cool because we can actually do things like I always like to put my name on it, right? Hey, I wrote it. Why not, right? What's the date? What does it do? What's the assumptions? Maybe there's an algorithm. I'm just putting some steps here. And always come up with a name that matches it. This is my little logo, the Crafty DBA. If you're curious, when you double click it, you can see the Markdown, okay? So you can do a lot of cool things here. This is a little avatar that I uploaded, and I can use it anywhere. So very first thing is, if we do fs ls databricks.datasets, okay, and we run this, okay, now what's interesting is out of the box is a bunch of pre-built datasets. Okay, and COVID has been something that has afflicted everyone in the world. Okay, so that's number one. But there's other ones like airlines, Amazon, so on. And we can also, there's different ways to do it. We talked about FS as file system, but we can do SH, which is bash shell. And so if we do that, and now we have to actually put the mount point there, which is the Spark mount point, we can see that this is actually textual, and this is not textual. Also, when it comes out in a grid like this, you can do anything you want. For instance, see if we want to do a bar chart, it's not going to make sense, right? But we could do a bar chart. Obviously, I just want a grid, and there's our grid, okay? Simple data sets. We're going to talk about the power plant data set. So let's look at the DBFS, Databricks Power Plant data, okay? So we're going to run this. It's a freely, you know how in machine learning, they have those free data sets. This is the same thing. This is like the Boston data set for housing data that comes with, you know, scikit-learn. Okay, so we have a bunch of TSV files here. Okay, so we have 1, 2, 3, 4, 5 TSV files. So no, what we can do is we can run a bash command, and we do the cat. And cat means catalog, right? In Unix, and if we run that, it's going to print out, okay, what's inside the file. So we can see there's some things here. I don't know what they are. We can also look at the README file. So I am going to set the path to this PowerPoint. I'm going to open it. I'm going to join lines and print lines. And so if I run this, I'm not going to, but you can see it. And if we went to this URL for the source, I actually cut it out, and we can actually do something in a here document. And I wanted to know, hey, guess what? That T, okay, is for temperature. AP is for ambient pressure, so on. So now I have a guide or a data dictionary of what that table was, okay? Let's read it up to do something. So far we've cat it, but we haven't really transformed it into a data frame. So source.path is equal to the path, and I could put a particular one here, but I'm telling it, hey, I want to read all the TSV files up, okay? And I want to the data frame.plant is equal to, and these are power plants, spark.read, formats TSV. Well, you said, well, it's a tab delimited. Well, it's a CSV format, which is some type of separator, but we're going to change the delimiter to tab. We're going to give it a header. We're going to quote it, and we're going to infer the schema. We're going to load it, and we're going to tell it, hey, I want 4 partitions, okay? I'm going to partition my data, just like I said you can. So when we run the cell, okay, this is actually going to execute this, and it's going to display the data. Okay, and we can see that, oh, I must have had at one point a line graph here. So I'm plotting V, and what is V? I forgot what V is, but it's the vacuum over what? AT, which is, I assume, the temperature. So we could do, you know, temperature over pressure if we wanted, and that's easy enough to change, right? We can go to plot options, right? We can say, okay, we want to do AP, pressure over temperature, and hit apply. It's going to run the query again. And now we're going to get a pressure over temperature graph, okay? So, and we can also, if we didn't want to look at that way, we could also just look at the raw data, and this is the raw data, okay? So, one thing you do when you do Databricks and you do a data lake, the first thing you want to do is set up some type of directory structure. So the RI is the Rhode Island SQL Server User Group. We probably should rename ourselves to maybe like a data platform group, but we've been meeting for the last 12 years. So, even though we talk about anything, we're still called that. And so we would create the root directory, and then we can create, and again, I commented these out, but if I run them separately, I could create the bronze, silver, and gold like we talked about, okay? And so we could list in the bronze directory, right, what's there. And so if we run this, we can see in the bronze directory, we have some, the FHI, the green taxi, the lending club, the payment, the power plant, some rate codes, yellow taxi, and zone. Some of these files are really huge. So I'm not going to remove them all. I'm just going to selectively remove 2 of them. I'm going to reload the power plant right now because I told you how to read the power plant data. This is the spark.read. But I want to show you how to do the spark.write. And we're also going to do the lending club later on too. So I want to show you how to do that. So I'm going to run this code. And this says, hey, remove this directory on a first. And it's going to force the directory removal recursively. We see this power plant here and this lending club here. And now if we run this again, we're going to see those 2 directories disappear. Okay. We can also do some interesting format. We can say format of the count, and we can just do, a format of the string right there. And if we run it, we can see there should be around 50,000 rows. There is. And then last but not least, we just say, hey, it's a destination path, and then please write to that destination path. So we're going to overwrite it. Okay. And we run cell. Okay. And now if we go ahead and we look at it, let's take a look. Now, we wrote this as a parquet format. So you would say, oh, yeah, I might have one file. But if we look at it, we have multiple files. And the question is, why do we have multiple files? The reason why we have multiple files is because we told it to partition by 4. So we can see this is first file C00, and then 2, and then 3. So we have definitely 4 files here. 1, 2, 3, 4. And we also have some extra information that happens when you write with Spark. For instance, success, we have committed and started, okay? And so far we talked about just reading CSV or TSV and writing to Parquet, but it supports Avro, CSV, JSON, Parquet, text, and JDBC, any type of database connection out of the box, okay? So let's go back to processing files and talk about that. Okay. So weekly type files can take more time to process if you're inferring the schema. So I don't know how many people use Excel. And again, this is kind of interesting to do this live on YouTube because I don't see any feedback. But the cool thing about Excel and bad thing is you could have a file and put CSV on it. And you could have like 500 rows and it would be all numbers and it's only an A. And when you load it up, it might complain, right? Especially if it's a CSV. And the problem is it inferred that, hey, it's a number, but you gave it an alpha, right? So the interesting thing is you can create something. Yeah.
Yes, I had an issue with that inferring file, right? Infer schema.
Yes.
You know what we're talking about? Yeah, we had millions of rows in JSON file. And we couldn't have the complete schema from the provider.
Yep.
So we had to infer schema all the time, and it was taking a lot of time. So it's easier to get the real schema, I would say, the final schema from the provider, and then after that you infer the files, because otherwise it has to read the files entirely to infer schema, right?
Yes, it does, and that's the reason why it's fast at processing. Also, like Excel, it used to blow up. And one last thing while we're talking about that, and a good point, is that if we go back here, and if I think I do df underscore plant dot print schema, if you're ever curious and you wanted to get it, you can run this and it'll tell you what the type is. And we can see that these are all doubles. So if you didn't want that, you could create something like AT a schema. And again, I'm doing this off my top of my head. It's a little off practice, but for instance, we could do AT double, right, and then V double, and so on. And so that way would be your thing, and you just call the schema 1 equal to, and then when we did this actual load, way back, it's way back here somewhere. Yes, instead in first schema you do false, and then you just do schema equal to, and then you put that schema in, and that would basically make it read a lot faster, right? And you were having problems because you had to read, like you said, would you have huge JSON files?
Yes.
Yes. So
millions of rows.
that's why you have it. I hate JSON too. It bloats.
I know.
So one of the problems you might have, and again, we'll talk about it really briefly, but is what do you do with a corrupt record? What do you do with it? Do you stop the whole processing? Do you ignore it? So on. So we'll talk about that. But initially, we want to extract and validate the data, apply a schema. So we talked about that, handle the corruption, and load and automate. Okay. And PySpark. Well, what can we do with SQL, right? So if I just only showed you how to read and write a data frame, but we want to really get to SQL, right? Well, the interesting thing is there's whole types of statements for dropping the database, dropping tables, dropping views. They're all supported by cataloged, right? And Spark.SQL allows you to dynamically write anything that is valid. And what's going to do, it's going to translate it over into the same code that's going to be used for Java bytecode, right? That's how everything's run on a JVM. Either it's data frame, dot, like join or whatever, merge, or it is like, select star from table 1, left join table 2. And that's the same command, but eventually the code gets to Scala, and that's how it works. So the magic command %equal, I already showed you, just allows you to do it. You can also do the create a temporary view. So in example 2, which is the New York City cab data, and this is huge data, and we'll talk about it. I didn't want to redo it. I'm just going to delete and then attach them, and they'll take long enough. But if you actually load these, they'll take several minutes to load because, again, I'm only using 4 cores, and it's going to take a little while. So let me just do a quick cleanup, knock those 2 things I added. So I want to get rid of this, confirm, and I want to get rid of this, confirm. And then what we're going to do is we're going to go back to my workspace, and we're going to talk about managing the New York City cab data. Okay, so in this one, the New York City CAD data is in this directory called Databricks Datasets. It's open datasets they give everyone. New York City, we can do the README and find all about it. We can also say, hey, let's show the databases I have, right? And databases are the ones that in here, the hive database they're called, okay? We can see there's a DIM, a FACT, those are VentureWorks. The default is where if you don't create your own database, that's where everything goes. There's New York City and report. And so we can also, on this one, we can display it. It's just a different way. And what we're going to do is we're going to drop database that exists and then cascade. So this is going to get rid of all our tables. So let's look at it really quickly. Okay. And so all these tables are going to go bye-bye. So say bye-bye, run cell. And again, don't do this with your big data administrator, otherwise, without telling them, otherwise he might get mad at you. But you can see it's gone, right? And what we're going to do is we're just going to recreate those from scratch. Not a big deal. So we have a bunch of data here. And if you look at this enough, there's a data integrity issue with the New York City yellow. Okay. We can also show you, for instance, a taxi lookup. So, and again, going over trip data for yellow, green, and for higher vehicles. And there's some reference data. Okay. So, we can remove stuff and we can reload stuff. Like this one says, hey, guess what? Make a directory if I remove the directory. And then what we're doing is we're copying from the CSV file over to this directory. Okay. And we're getting rid of the extension of the name and so on with this one and so on. We do these to get the files in the right place. And what we can do is we can actually start creating actual tables. So for instance, Spark.SQL allows you to run any SQL. And I'm saying drop table, the New York.payment. Now, this is going to fail because I'm doing a try. And except means, hey, I don't really care. I just wanted to drop table if exists, and there's no such thing. Then I'm going to say SQL statement, create New York.payment type using CSV, give it the path, options. I have a header, and just run it. So now, if we go ahead and just run this cell, did I create database? Maybe that's what I didn't do. Show databases. I play with this, so maybe I did not do it. Yeah, I just didn't run it. That'll be helpful. So now if we look at data, we should have New York City and it should have no tables. Awesome. So that was the error, and that was a little step I forgot to tell you. Let's run this again. So now if we just run the whole cell, and now we can go ahead and say select star from payment type, and we run, and suddenly it goes. Now you can run the rest of this by hand at your own leisure. Like I said, some of these actually take a long time. So we're going to run the rate code. And if we run the rate code, these are just little lookup tables. So now we're building our data lake, right? This is what we'd be doing in production if you did some pipelines. And maybe you'd use a metadata-driven approach, so you wouldn't have to write the program over and over again. So we're going to do a zone lookup. So now we're going to run this cell. And you can see this is pretty repetitive. Hey, create table, give it a name, use CSV. We happen to use CSV. I'd use Parquet if I was doing production. Yeah, it has a header. You don't need to do that with Parquet, but CSV you do. And then guess what? Run it. And then at this point, maybe I want to know, hey, give me every data, but then I want to order it by service zone borough and just show me 10 rows, right? And that's what this code does, okay? So we can see we're leveraging our SQL skills in Spark. Once we post it, and it's a really small piece of code, right? Drop the table and then create it given a path. Now I can use SQL and I'm all done. I'm basically a big data programmer, okay? So I can also look at the counts. So if I'm curious about counts, I can say, give me a count. It's there. I can also do the yellow cab, okay? And the problem with the yellow cab, it's huge. So this might take a little. Okay, not that bad. And now if we run it, okay, we're going to see there's 1.6 billion rows of data. A lot of data here, right? And so what we can do is we can look at the CMT limit 50. And what I'm trying to show you is, see this rate code ID right here? It's null. That's a data integrity issue I found, okay? And how do we fix that, right? Well, the only way we can fix that is we have to rebuild it, right? So we could read from the original CSV and gzip files and then get a count, and we can. That's there. We can show, right? And then this is the code that we could go ahead, similar to the other one, we just copy data over, and then we could do the green city cab. So we're going to run this one. And I'm going to skip over that data integrity issue. I'll let you fix it if you want. And then I can select the top 100. And now we're getting the green cab. And unlike the billions of rows, the green cab's only going to have 25 million rows. So it's a small data set. Or is that billion? Hang on a second. Thousands, 700,000. No, it's 25 million. So I want to go back to this code that I wrote here. And it's in here. I want to show you a couple things I did. One thing is we're going ahead, and this one has the option to do when something happens. So if we have a bad load and it's malformed, then what we're going to do is we're going to drop the record, okay? That's one way. Also, some of these formats do not like spaces, right? So I don't want to, I'm saving as a Delta format. So to save as a Delta, I don't want a space there, so I'm renaming it. Okay, these are all done with Spark data frame commands and then write to save it, okay? We talked about green. We talked about we can run this because this is there now, right? Okay, and then we already looked at the number of rows, right? So that tonight, yep, 420, 25 million. We can also do a LS of the yellow taxi. We can see the taxis there, and we can create. So we can drop the table, and we can create it using the new delta that I reload, okay? And let's see if this new delta has that fix, and of course it will. And so now if we go ahead and we run it, so a lot of times when you do this, you'll find upstream maybe a bug, like a data problem with your file. So maybe you'll have to ask for a new set of files. And it's not uncommon. And guess what? This one's been fixed now with the right rate code, right? And then we can run it again. We see it's at 1.18 billion rows. We can run the very last one, which is for hire vehicles. And again, this is repetitive. Before we did CSV, then we did Parquet, now we're doing Delta. All these formats are supported. And then if we run the for hire vehicles, we can see some data and we can get to some rows. I'm going to skip a list. It's 260 million rows. So this is the most important thing out of the whole thing I talked about tonight. If you go to this link called spark.apache.org.docs.latest.api.sql, it basically has a cheat sheet of all the commands that you can use in Spark. And you can look at the differences. And I'm going to point out one that is most important is the is null, right? So is null in SQL, we do is null, comma, if it's null, replace it with a value, right? But in Spark, if it says null, it returns a function. So how do we rewrite this to work like SQL? Say if we had something written in SQL and go in the data lake. Well, we can get around that with the if statement. So we can say if is null of a value, then we put the value that we want to replace it with, otherwise the value that we initially have. So that's one way to write it, okay? So if you're curious, that's a point out to some things that are different that you'll have to contend with when you're porting over code. Okay, so we're going to talk about the lending club data. Now, lending club data was something that was used in machine learning. I took some of the things because it did some interesting things for regex and how to process some stuff. I've done regex myself when working with clickstream data. So one of the things I want to talk about is dot select. There's a ton of dot on the data frame, different functions you can use. Please refer to the documentation. I can't teach them all tonight. However, the dot select is used to reduce the number of columns, okay? So that means that this way, if we have price and quantity and total, and we just want price and quantity, you can just get rid of column by selecting. With column allows you to either reformat it, create new columns, and where allows you to reduce the number of rows. So we can say where the sales is in 2021, and guess what? Maybe we had two sets of rows, 2020 and 2021. Guess what? 2020 goes away and we only have 2021. So let's talk about the lending tree club data set. We got two more to go through and then we're on the home stretch. We're done. But I just, this is all good foundational stuff. And you have to teach it. Otherwise, if you get into your first job, you're going to be like, okay, no one even showed me any of these techniques. And I definitely do not want you to go out there unprepared. So again, it always prompts you, hey, if there's an error or something, make sure you get your cluster ground. There's sometimes things happen to your cluster. I've had it in which, you got some weird code going on, your cluster goes done, you can detach, try to reattach. You can also restart the cluster, okay? And so those are your commands, just want to point them out. This is where the lending club is. So we have a CSV file and we have some text. If we cat the text, it'll tell you all about what's inside here. We can also make a directory. So what I'm going to have to do is I'm going to have to make this directory because I got rid of it, if you remember at the very beginning. And if I had, almost 2 hours, I'd run through all the examples. But, bad enough, it's about an hour and 5 minutes. So doing pretty good. So this actually is removing it. And it copied it over. So now if we go ahead, we can read in the CSV file and say header equals true. And then we can select just a subset of the fields. So we don't want all the fields, and then we can display it, okay? So let's run this. And let's take a look. Okay, well, this is typical of like any type of data engineering that I do in big data, because you'll get some data from a source and it's not in the format that you want. For instance, interest rates, they have percents at the end. And when I want an interest rate, I'd want 0.2039, right? It's 20%. It's not this, right? It's a fraction. Also, we might want to convert, employee length to 3, 6, 8. 10 plus might be just 10 or whatever you want. NA, maybe 1 or whatever. So there's some data cleanup we need, and we can click a count. So if we run the count after we do it, we can see there is not that much data. It's only 130,000 rows, okay? One of the things you want to do when you import, actually work with these functions, you have to import the PySpark SQL functions, okay? And then you can actually start doing some interesting stuff. So let's look at this line, loans equals. So what is loans? Well, we set loans equal to, we read the raw file in, we selected some columns and set it to loans. So loans is a subset of the raw data. That's all it is. and we're going to process it even more. So we're going to say loans is equal to with. We're going to create a new column called bad loan. Well, how is bad loan defined? Well, if the loans, okay, dot loan status is in current or fully paid, and you see this tilde means not, then it's a bad loan. It's going to give us true or false. We're going to save it as a string. Okay. We're also going to go ahead and create some things. For instance, we're going to redefine init rate. We're going to replace the %. We're going to cast it to a float. Same thing with a revolving utilization issue year. We're going to grab 4 characters, just a year. We're also going to figure out the earliest year, okay, is equal to 4 characters double, okay? And then the length of year is the issue year minus the earliest year, so it's a calculation. And then employee length, we have a bunch of stuff we want to get rid of. So we only want 1s and 0s. If it's less than 1, then we make it 0. If it's greater than, and see we have to escape, then we want to make it 10. We want to display it, and then we can repartition it and write it back out, okay? So that's what's going to do is we're going to basically take our data frame, manipulate it, and then write it back out as a 2-partition parquet file. And if we look, hopefully it ran. I can't tell. It went so fast. So file run. Yep. Is that exception? Okay. So the problem is I thought I already got rid of this, but saying it existed. Oh, yeah, because I ran it a second time. Okay. So that's the reason why. So at this point, we have the file here. It says existed. So if we want to do this over, we'd have to put a overwrite command. There is an overwrite force on the parquet. I don't know it right off the top of my head. So I'll let you look that up. One of the things we can do now is once we have it there, we can pat to this single parquet file, right? And if we look at it, it was process1.parquet and repartition 2. So this is actually a directory even that says parquet, okay? And what we're going to do is we're going to load it up and we're going to create a table. So if we look, this is the loan club process 01. So if we go to data and we look, we have loan process club 01, and that's the data. And we could click into it and get the headers and the sample look at it, but I don't want to do that. So what we can do is also if there's ever a time in which the parquet gets out of sync, unlike a delta, which automatically handles, you can do a refresh, okay? And now if we do a count, which I can do, we'll get 130,000 rows. Boom. What's interesting is that we can do the same statement, all this code up here, but in SQL. So someone at one point decided to do all this fun stuff using functions like regex, replace, and loans, with columns and so on, using the functions that are part of PySQL with data frames. But we could do the same thing with using T-SQL, and I like T-SQL when I can do it. So I'm going to replace the actual club, this temp loan club. I'm going to make it off the data frame. And now I can start using this temp loan club for anything. So we can see this is the original data, which had even more fields than we're using, right? So we need to select down a number of fields, okay? So we can do that by changing it just in a select statement, right? Select ABC for columns and we get ABC. So we're going to loan status. And we can do these things that we're doing before. So for instance, we can go do a replace of % to nothing as a float, cast it, and then save it. And we have this one. This is a substring. This is take these 2 substrings after I cast them to doubles, subtract them and create it as years. And the very ends do a replacement for this regex with less than 1, 0, greater than 10, 10, and the rest, and then the bad loans, right? So bad loan, when the status was current, we want to say false. If it's fully paid, it's false because it's not a bad loan. Otherwise, the bad loan's true, right? And so we're going to write it out, repartition to parquet number 2. So this is the same statement, but it's all in SQL. And okay, well, I must have not deleted the files, but anyways, it's saying it's still there. So there's a file there. I'm going to create it and show you the results. So if we run. So now if we run this and do limit 10, we can see that we have the similar information we had before. So interest rate, revolving utility, issue year, earliest year, credit length in years. There's a bug in this because it's negative, so it might be the other way around. But that's the second to last example, okay? Last but not least, we want to explore a data set with SQL. So this section of the presentation is to reinforce the fact that SQL skills are applied in PySQL. And we'll be looking at both some advanced and simple constructs that are available, okay? So we're gonna look again at the lending tree data, but we're gonna do something a little more advanced. We're gonna do like a windowing function, maybe a CTE, some cool stuff. So last but not least, we go into PySpark talk, and we can say, hey, show the tables in New York City, and we can see these are all the tables, right? And if I want to go ahead and select from the second one, 10, we can see there's 10 of them, right? So that's what we have there. I can refresh this, right? This will work, perfect. Okay. So what we want to do is, I live in the Northeast of the United States. So what we want to do is we want to know bad versus good loans and the average amount of loan. To do that, we can select the address state, bad loan, the count of the loans, the actual amount. Okay, we're going to round it to 4. From the second process, where state is in one of these states, and these are the New England states, having the loan amount greater than 0, and so on. So if we run this, we can see the actual ones that bad loan equals false is these are good loans. And if we look at it, Massachusetts has 65 bad loans. Connecticut has 38. So this is a small company, 11. Try 8. Vermont, 7. So let's see if this works again. So run it. And we get the same results. So it's great. And we basically did a bar chart. If we do plot options, we can see it's a group bar chart. We get address, bad loan, right, false, true, number of loans, okay? Let's do something a little more complicated. So we noticed that there's years there, but the year, if it's less than 50, then more than likely it's add 2000 to it. So it's 2000 through 2050. If it's greater than or equal to 50, you probably add 1900 to it as the loan year and the loan amount. So this is a subquery that we're going to use as a CTE. So let's run this. So now we can see the address, the loan year, and amount, right? Let's do something a little more complicated. Say if I wanted a running total, and I want to know by year, by state, the first loan followed by a running total, the second loan, the third loan, the fourth loan, and so on. Well, we can use this as the subselect for the CTE, or the derived table. And so with CTE, we have this right here. Then what we're going to do is we're going to select from the CTE. We're going to partition row number over, okay, partition by the address, by the loan year, between unbounded preceding and current row. That's our loan ID. And then we're going to do a running sum with the sum amount, okay? And so if we run this, okay, and it's thinking, and it's probably going to tell us that we can optimize it by doing something or another. Yeah, if we look at this as delta, optimize the order by, so we can use, but we can see that the very first loan in Connecticut in 2011, because we said greater than 12, was 40,000, right? But the next one was 5,600, so running total is 45,600. Next one's 10,000, so it's 55,600. Next one's 5,000, so on. And we can scroll all the way down through the year, right? And if I remember right, we're grouping by year. So at 2011, nope, we're just grouping by, I guess, state. So at 2011, it just keeps on running. Okay, and at the very end, when we switch states, which would be Massachusetts, we're going to see it resets. So where's Mass? Right here. We can see Mass resets, okay? So I'm going to close. Hopefully no one's fallen asleep. No, it's a lot of information. But
that's very interesting, John.
Why did it stop? Hang on. Shoot. Hang on.
It happens.
Of course, when you do live demos, everything destroys on you. Hang on. Come on. Do you still see me?
We still see your presentation. We'll just Yeah, I see a task manager here.
Yeah, let me see if I can get the top. It's almost done. Don't blow up on me. I love it when it blows up. So I'm going to conclude that,
Yep.
you know, I wish my PowerPoint didn't blow because it worked all for the hour and a half and to the very end, but now it blew up. So,
That's
hey,
nice.
whatever. It's the way it is. But in conclusion, you know what you can do is just remember this. You need to learn about how to manage file directories and files in the data lake, how to not only do it with attached storage, but also local storage. Second thing, reading and writing the results important because you read in a raw file, you transform it, you write it back out. Once you attach the file to Hive, any of those skills, or even if you just read it in as a data frame and you create a temporary view, you can use any SQL skills that you have. So that means you can transform the data using SQL. And then last but not least, when you do a dot write, it writes it back out. And that's how you do big data engineering using your T-SQL skills using Spark. So I hope you enjoyed the presentation tonight. It was a blast as usual. And, you know, again, looks like everything's dead on me. So, but
it's fine. Your PowerPoint is dead, but the presentation was good. People liked it. And you were so clear that we don't have any questions so far. So
okay.
Very good, John. Thank you.
Thank you.
Thank you. So guys, the video will be available on YouTube. So from now on, you can access that amazing presentation on YouTube. Thank you, John. Thank you, guys.
You're welcome. Thank you, Michelle, and thank you, Christian. I'll talk to you soon.